Hello, I'm Sri Lekha. Today, in this video, I will teach you how to multiply matrices. First, let's see the representation of matrices. Consider a matrix A, which is represented as Aij m by n. A is the element in matrix A that represents that the element A is in the ith row and the jth column. M by n is the order of the matrix that signifies that matrix A is of the order m by n and it has m rows and n columns. Let's see a few examples. For example, the first one, 147 has one row. So m is equal to 1 and 1, 2 and 3 columns. N is equal to 3. Therefore, order is 1 by 3. The second example has 3 rows and 1 column. Therefore, 3 by 1. The third example has 2 rows and 2 columns. Therefore, of the order 2 by 2. The fourth example has 3 rows and 3 columns. Therefore, of the order 3 by 3. The fifth example has 2 rows and 3 columns, therefore of the order 2 by 3. The sixth example has 3 rows and 4 columns, therefore of the order 3 by 4. I hope that was clear. Next, multiplication in matrices is of two types, scalar multiplication and matrix multiplication. Let's see what scalar multiplication is like. Scalar multiplication of a matrix with a number is just multiplying the number with each element in the matrix. For example, in the first one, 2 into 1 is 2, 2 4s are 8, 2 7s 14, 2 2s 4, 2 5 is 10, 2 7 14, 2 11 22, 2 times 0 is 0. Therefore, it's just multiplying 2 with every element in the matrix. The next example, 5 ones 5 0 0 0 5 0 0 0 5. Now that was matrix multiplication. That is multiplication of two matrices. Consider a matrix A with order m by n and B with order n by p. The first condition to multiply two matrices is that number of columns of the first matrix should be equal to the number of rows of the second matrix. That is n here and n here should be the same thing. And the order of the resultant matrix C, which is equal to A into B, will be m by p, that is number of rows in the first matrix by the number of columns in the second matrix. Now let's see how to multiply these matrices. The first matrix is of the order 2 rows by 2 columns. The second one is also of the order 2 rows by 2 columns. We have to multiply every row of the first matrix with the elements of the columns in the second matrix. Therefore, the first element will be row 1 multiplied by column 1. Second one will be row 1 multiplied by column 2. The third element will give us the next row. Therefore, row 2 multiplied by column 1. The fourth element will be row 2 multiplied by column 2. Let's see how we do this. Therefore, row 1 into column 1 will be 1 into 2, 2, plus 2 6 are 12. 1 into 4, 4, plus 2 8 are 16. The second row will be 7 into 2, 14, plus 48. Next will be 28 plus 64. Therefore, it comes out to be 14, 20, 62 and 92 of the order 2 by 2. Now, the resultant matrix will be of the order 2 by 2. And since 2 and 2 are equal, matrices can be multiplied. Now, If we consider this as A and this is B, let's just see what will B multiplied by A gives us. Now, following the same rule, row 1 multiplied with column 1 will give us 2 plus 28. Row 1 multiplied by column 2 will give us 4 plus 32. Row 2 by column 1 will give us 6 plus 56. Row 2 by column 2 will give us 12 plus 64. That comes out to be 30, 36, 62 and 76. The order being 2 by 2 and 2 by 2, since the number of columns in the first matrix are equal to the number of rows in the second column, the matrices can be multiplied and the order of the resultant matrix will be 2 by 2. Therefore, 2 by 2. Now you can see that A multiplied by B is not equal to B multiplied by A. Therefore, in general, A multiplied by B is not equal to B multiplied by A. Now, the order of this matrix is 2 into 2 and the order of this matrix is 2 by 3, 2 columns and 3 rows. Therefore, the order of the resultant matrix will be 2 by 3. That is something like this. Therefore, row 1, column 1, 4 plus 70. Row 1, column 2, 8 plus 77. Row 1, column 3, 12 plus 0. Now, row 2, column 1 is 1 plus 0. Row 2, column 2 is 2 plus 0. Row 2, column 3 is 3 plus 0. Therefore, comes out to be 74, 85, 12, 1, 2 and 3. Order of the resultant matrix is 2 by 3. The next example. The first matrix is of the order 1 row by 3 columns. The second one, 3 rows by 1 column. Therefore, the resultant matrix will be of the order 1 by 1. So, it will have only one element in the matrix. Let's solve the matrix. To solve, we multiply the elements of row 1 with column 1. Therefore, 1, 1 is 1, plus 2, 2 is 2, plus 3 3s is 2 2 is 4, and 3 3s is 9, and therefore the answer comes out to be 14. 1 by 1 matrix with just one element. Matrix is of the order 3 rows by 1 column, and the second matrix is of the order 1 row by 3 columns. Therefore, the resultant matrix will be of the order 3 by 3. That is of 3 rows and 3 columns. Now let's evaluate. First, we take the first row multiplied with the first column is 1 1's 1. First row with the second column 1 2 2. First row with the third column 1 3 is 3. Next row, second row with the first column 2 1's 2. Second row with the second column 2 2's 4. Second row with the third column 2 3's 6. Now, third row with the first column 3 1's 3. Third row with the second column 3 2's are 6. Third row with the third column 3 3's are 9. Therefore, this is the resultant matrix of the order 3 by 3. Next example. The first matrix is of the order 3 by 3, 3 rows and 3 columns, and the second one has 3 rows and 1 column. Therefore, the order of the resultant matrix will be 3 by 1. So, by 1. Now let's evaluate. First row, the first column will be 1 1's 1 plus 1 4's 4 plus 0. Second row with the first column will be 7 1's are 7, 4 2's are 8 plus 3 3's are 9. Then the third row with the first column will be 1 1's are 1 plus 4 4's are 16 plus 9 3's are 27. Of the order 3 by 1. That comes out to be 5, 24 and 44 of the order 3 by 1. Thank you for watching. I hope that was helpful.